Unit 6, Day 5, Properties of Logarithms, Day 1. Your learning target today is to use your properties to simplify logarithmic expressions. Because logarithms are exponents, you can derive the property of logarithms from the property of exponents. In the past, we have looked at b to the m power times b to the n power, and we can combine those and say it's equal to b to the m plus n. You can see the example to the right, x to the third power times x to the fourth power is equivalent to x to the 3 plus 4. So if we're looking at log with a base 2 of 16, we ask ourselves 2 to what power is 16? We know that that's 4. We can also rewrite 16 as 8 times 2. So log with a base 2 of 8 times 2 is also 4. We can also separate that into two logarithms. Log with the base 2 of 8 is equal to 3. Log with the base 2 of 2 is equal to 1. And when we add 3 plus 1, we also get 4. The product property of logarithms state that if you have a log with a base b of m times n, that is equivalent to log with a base b of m plus log with a base b of n. The product property can be used in reverse to write a sum of logarithms, exponents, as a single logarithm. Express as a single logarithm, simplify if possible. So example number 1 says log with the base 6 of 4 plus log with the base 6 of 9. So using our product property, we can multiply our 4 and our 9 together to get log with a base 6 of 36. We now ask ourselves 6 to what power equals 36, and we know that it's 2. Example number 2 says log with a base of 1/3 of 27 plus log with a base of 1/3 of 1/9. We can use the product property, multiply 27 and 1/9 together. So remember, we multiply fractions straight across, and we get 27/9. We can then simplify 27/9 to 3. So 1/3 to what power is equal to 3, and we get -1. If we're looking at this next slide, b to the m power divided by b to the n power, it is equivalent to b to the m minus n. If you look at the example at the right, you can see x to the 8th over x to the 5th is equivalent to x to the 8 minus 5. This is the definition of a quotient property of logarithms. If you have log with the base b of m over n, you can rewrite that as log with the base b of m minus log with the base b of n. In order to simplify logarithms, they must have the same base. Example numbers 3 and 4 ask us to express as a single logarithm and simplify if possible. So the first thing we notice is there is a subtraction sign in between these two logs. Therefore, we know we want to use the quotient property. The quotient property says we can rewrite our logs as division. So 49 divided by 7, log with a base 7 of that. 49 divided by 7 is 7. Log with a base of 7 of 7 is equal to 1 using the property we've learned on the previous day. Again, example 4 says log with a base 5 of 4 minus log with the base 5 of 100. We can rewrite that as 4 over 100. So we're looking at log with a base 5 of 4 100ths, which simplifies to 1/25. We ask ourselves 5 to what power is equal to 1 over 25. In order to get a fraction, we know we need a negative number, and it's a -2. Because you can multiply logarithms, you can also take powers of logarithms. If we have log of 10 to the 3rd power, we could rewrite that as log of 10 times 10 times 10. We could take that a step further using the product property, and we could rewrite it as log of 10 plus log of 10 plus log 10. And we could even take that a step further, and we could say we have 3 log 10s. The power property of logarithms states that if you have log with a base b a raised to the p power, you bring this p down to the front, and it's now p times log with the base b of a. Express as a product, simplify if possible. So example 5, the very first thing I notice is that I can move my 6 using the power property. So I now have 6 times the log with a base 2 of 32. I then ask myself, 2 to what power is equal to 32? 2 to the 5th power equals 32. Then I multiply my 6 times my 5, and I just simplified my logarithm. Example number 6, I'm going to bring my 20 down in front using the power property. Rewrite log with a base 9 of 3. I ask myself, 9 to what power is equal to 3? Just the 1/2 power. So 20 times 1/2 is equal to 10. Looking at example 7, I noticed I'm missing a logarithm right here. So I know that that is a common log, so I can put a 10 there. I'm going to bring my 4 down using the power property, so I'm now looking at 4 times the log with a base 10 of 10. I know that equals 1 times 4 is 4. Power property says bring that 2 down in front. Right now I'm looking at log with a base 25 of 5. I ask myself, 5 to what power is equal to 25? 5 squared is 25. 2 times 2 is 4. So you now need to memorize these 3 new properties.